Now here, we're going to be using these properties a lot later, okay? We might use them a little bit now, but we're really going to be using them later on. But I just want to put them in here a little bit because we're talking about exponents. And I want to give you a couple of examples to show that there's some reason to believe that they make sense. And then we'll see them in use later on as they become necessary. Okay? Okay, so in general, if I have x raised to the 1 over nth power, that's going to be the nth root of x. And in particular, if I want to take the square root of x, that'll be x to the 1/2. Okay. So what I'm going to try to do right now is the reason why I'm showing this right now is that I'm going to try to give you some feel for why these are true. This is not going to be a proof. These are just going to be a couple of examples to motivate that these properties make sense. Okay? And we'll see them used. And then, of course, later on, as we need them more, I'll recap them during the course of examples that need them and so on and so forth. So let's begin like this. I know that the square root of 4 is equal to 2, right? And we know that because 2 squared is equal to 4, right? We say that a number, we say that the square root of a number, like this is basically the defining characteristic of the square root of a number. The square root of a number is that number such that when we square it, we get the number back. Okay? So what I want to show you here is what happens if I do 2 squared raised to the 1/2 power. Now, the argument we made about how the properties work does not apply to fractions, but I believe you'll accept, at least for the time being, that this becomes 2 to the 2 times 1/2 power. Okay? In other words, I'm kind of hand waving here, but this is actually true. Okay? And then from here, 2 times 1/2, that's just 1. Okay? So this becomes 2. But what is 2 squared? That's 4. So what I just showed you here is that 4 raised to the 1/2 power is 2. And we know that the square root of 4 is 2. So it is reasonable for us to believe that that in fact this property makes sense. Okay. So now I'm going to give you another example. Okay. Okay. Now let's imagine I have let me imagine that I take the cube root, okay, the cube root of 8. I ask myself what number times itself 3 times gives me 8. Aha, it's 2. Why? Because 2 cubed equals 8. So what I want you guys to realize is that the roots of numbers basically go in the opposite direction as exponentiation. So whereas 2 cubed equals 8, the cube root of 8 is 2. Okay, you see, like here we went 2 cubed equals 8, and here the cube root of 8 is 2. Okay. Okay. I know that all of you can probably already see where this is going. What happens if I take 8 to the 1/3 power? Aha. I can replace 8 with something that it equals, namely 2 cubed. Right? Oops. Right? So 2 cubed to the 1/3. Right? So 8 to the 1/3 must obviously equal this because 2 cubed is 8. And I have here 8 to the 1/3. Aha. But because of the property we used before, we know that this can be written as 2 to the 3 times 1/3. Right? But what's 3 times 1/3? That's 1. And so therefore this is just 2 to the 1 power, which is just 2. Okay. So again we see that these properties make sense. These properties make sense, and moreover, these properties do carry, do mesh with our intuition about what roots are supposed to do. And of course, I'm just gonna do one more example here. And again, I'm sorry I'm using the number 2 a lot, but it's just because these are nice numbers that are easy to know. I'm gonna make a little bit of a change here when I do this next example, and then we're gonna move on. So now, you guys may or may not know this, but the fourth root of 81 is actually 3. Because 3 times 3 is 9, times 3 is 27, and then times 3 is 81. Don't worry, I didn't do that in my head. I wrote it down ahead of time, I promise. And you can verify that as well. So, but that is true because 3 to the 4th power is equal to 81. Okay? So reasoning as before, by analogy, we can imagine, 81 to the 1/4 power must equal 3 to the 4th to the 1/4 power. Using the property that we cited above, that's the same as 3 to the 4 times 1/4. But what is 4 times 1/4? 4 times 1/4 is 1. So this is just 3. And so we again see that raising to the 1 over nth power is identical to taking the nth root. That these are the same relationship. Similarly over here, that taking the square root is the same as x to the 1/2. In other words, this one in particular is a particular case of this more general rule, but I wanted to highlight this one special because, of course, square roots are used a lot more. Yes. Thank you so much, and I'll see you soon. Thank you.